53 million years ago, the shores of Antarctica were lined with palm trees, and temperatures hovered comfortably above 20 degrees Celsius. Similarly, the arid, lifeless dunes of the modern Sahara Desert were once a lush, green landscape carved by massive prehistoric rivers. Today, both regions are defined by extreme hostility. We tend to view the surface climate we experience today, the mild conditions we rely on to grow crops and build cities, as a permanent fixture. In reality, it is a highly vulnerable, temporary sliver of geological time. If the current polar ice caps were to melt entirely, the immediate consequence would be the erasure of our coastal landmasses. Huge sections of Florida, the Netherlands, and heavily populated Asian coastlines would slip permanently under the rising water. This map of global ocean currents shows how an influx of melted ice disrupts the wider aquatic system. Notice how the Gulf Stream completely stalls. As billions of tons of fresh water pour into the ocean, it drops the overall salinity, shutting down vital thermal currents that regulate global weather patterns. The danger extends beyond the water itself. Deep inside the melting permafrost, ancient, dormant toxins and viruses, biological agents humanity has zero immunity to, are waiting to be released back into the atmosphere. The surface of our planet is exceptionally fragile. To understand the true resilience of the Earth, we have to abandon the surface and descend into the absolute extremes of its depths. Our first descent takes us 4 kilometers straight down through the solid, freezing mass of the Antarctic ice sheet, heading toward a massive subterranean body of water known as Lake Vostok. This cross-section illustrates a physical paradox. Immense downward pressure from the ice above pushes against geothermal heat radiating from below, trapping a liquid lake. This 350 atmospheric pressure gradient creates an impenetrable seal, locking the water in complete darkness for millions of years. Despite that crushing pressure and a total lack of sunlight, this environment is inhabited. Samples pulled from Antarctic subglacial lakes contain the remains of complex microscopic life, like tardigrades and branching fungi, surviving in conditions that should logically shut down biology. Because this hidden ecosystem functions completely independently of the sun, it provides a working model for how life might survive in the ice-covered, high-pressure oceans of alien moons, like Jupiter's Europa. Leaving the ice behind, we plunge 11,000 meters below sea level, dropping to the absolute bottom of the Mariana Trench. This cross-section shows the violent tectonic mechanics that carve out a trench this deep. The massive Pacific Plate is being forcefully shoved underneath the Philippine Plate, a geological process called subduction, which drags the seabed downward into a massive V-shape. Reaching this depth requires extreme engineering. In 1960, the bathyscaphe Trieste was built as a heavy, reinforced steel sphere, specifically designed to keep its 2-man crew alive against the crushing force of 1,000 atmospheres. Down here in the midnight zone, sunlight is completely absent. The ocean water hovers near freezing, making it a place where complex life seems completely impossible. Yet extremophiles, organisms adapted to survive the harshest environments, thrive here. Their entire food chain relies on bacteria harvesting chemical energy from black smokers, hydrothermal vents shooting highly mineralized water heated to 450 degrees Celsius. These deep-sea organisms demonstrate that life can persist entirely independent of a star's light or a mild atmosphere. It extends the search for life from solar-baked surfaces to any planetary body with internal heat and liquid water. Our final descent bypasses the water entirely and cuts straight into the continental crust. In northwestern Russia, scientists spent decades drilling the Kola super-deep borehole, grinding their way down to a depth of over 12 kilometers. The mechanical strain of drilling this deep is staggering. A 12-kilometer drill string weighs around 200 tons. If standard steel pipes were used, the entire apparatus would snap and tear itself apart under its own immense weight. The project eventually hit an absolute physical limit. At 12 kilometers down, subterranean temperatures spiked to 220 degrees Celsius, melting the equipment and permanently halting the drill. But the extracted rock samples completely shattered existing geological models. Instead of the predicted dense basalt layer, scientists pulled up Archean gneisses, a deeply fractured ancient rock formation, that gave us direct access to materials formed 3 billion years ago. Inside those blistering hot ancient rocks, researchers found the fossilized remains of 14 different types of microorganisms. Organic life had embedded itself deep inside the solid, boiling crust, sealed away under this very well cap. The deep continental crust acts as a planetary time capsule. It preserves physical records of the Earth's infancy, while demonstrating an extreme biological resilience entirely separate from the surface world. Space agencies spend billions of dollars launching probes across the solar system to search for hostile alien environments, while a vast alien world exists straight down beneath our feet. We have found complex organisms surviving in isolated subglacial Antarctic lakes, entire food chains feeding off toxic boiling vents at the bottom of the ocean, and fossilized microbes sealed inside blistering layers of solid bedrock. The extremes we've explored prove that while Earth's surface conditions are volatile, the biological and geological systems beneath them have persisted through shifts from tropical poles to frozen deserts. The planet has spent billions of years cycling through cataclysms that the deeper biosphere simply ignores. Stabilizing the climate and preserving the ice caps is a matter of human self-preservation. While the Earth and its deeper inhabitants will continue to evolve regardless of the surface temperature, the narrow window of our current climate is the only thing that makes the planet a home for us.